Okay, so in the previous lesson, you have learned that um, complex number can be represented visually on the Argand diagram. For example, here you have z equal to 1 plus 1 plus I. Alright, so which of the following is the correct polar form of z, of this z? So you will learn here a polar form. So if you look into these options, which one is the correct form of the polar form? So recognize all of them. It has a cos and sine part, and they are I. So that means the left side is a real part, right side is imaginary parts. So this may be a correct polar form of this Z. Okay, complex number in polar coordinates. So at the end of this lesson, you will be able to represent a complex number in polar form. So you have learned that complex number can be represented in a standard form, which is z equal to x plus iy. So in this lesson, you will learn the complex number can be also represented in a polar form. Okay, so what is a polar form? So let's review again that on the Argand diagram. So you have x plus iy. So this is a hypotenuse. This is the imaginary part. This is a real part, and the distance between these 2 points is the modulus of the complex number, and the angle is the argument z. Okay, so in uh, angular notation form, usually in electronics, it can be represented in this way. And from the triangle, you can immediately recognize that cos theta equal to x divided by r, and you can rearrange back so that you have x equal to r cos theta. For the sine theta, you have the adjacent side divided by the hypotenuse. So you can rearrange back that you get y equal to r sine theta. So from here, what you can do is that you can substitute these two into the original standard form. Therefore, in a polar form, you will get the, actually r multiplied by cos theta is x, and r multiplied by sine theta is y. So this is a polar form of a complex number. That means you have the information about the argument or the angle from x-axis. So usually the argument is between pi, negative pi, and pi, because pi is 180 degrees. So this is pi. Okay, so and then here this is negative pi, or negative 180 degrees if it is measured in the clockwise direction. So for example, so let's see that we have two numbers, p equal to 2i, and the second number q equal to minus 1 minus 3i. So that you have this is a without a real part, this is a pure imaginary part, and this is a real part and imaginary part. Okay, so we want to express both of them in a polar form. So what we can do is that we can visually put them on Argand diagram. So let's start with Q first. Okay, I'll start with the cube first here. So for the cube, the what we want to do is that we can but because the polar form can be written as r cos theta plus I sin theta. So what we want to do is we want to have the r first, which is the modulus of the complex number. So the modulus is just a hypotenuse. Okay, the hypotenuse of this. Um, you can use you can create a right triangle here. So you get the modulus is equal to 2, and then what for the argument. So what you can do is that you can calculate them separately, because this is a 90 degree. So you have here is 90 degree is 4 pi over 2, right? So pi over 2, and then you can calculate this one. You can use tangent, sine or cos, but we can directly use tangent, which is the tangent of 3 over 1. So this is actually 3 minus 1. Then you will get that the angle is negative because it is clockwise. Okay, so you have a negative the argument. So in the notation, the angle notation, so it is can be written like this, or in the polar form. So you have here r cos theta, and this is cos theta. So you can just leave it like this, or to simplify it, you can have a, in a chapter 1 you learn about odd and even function. So cos is a even function. Okay, so it is even function because cos x equal to cos negative x. Okay, this is a property of even function. So that's why you have like this. And for odd function, so sine negative x is equal to negative sine x. So you can simplify and get the final polar form is like this. Alright, so for the second number, which is p equal to I here, you can in the standard calculation, you can find out the modulus as 0 square plus 2 square, because you don't have a real part over here. You don't have a real part over here. Okay, so yeah, you only have a imaginary part. So you have 2 because the distance is just 2. Okay, and then you also do not need to calculate because it is already known it is 90 degree or pi over 2. Okay, so you can immediately see that the angular notation is the distance to argument 90 degree pi over 2. So that you don't have a cos part, you only have a sine part, which is you can write it as a 2i sine pi over 2. Okay, all right. Okay, so for the teaser, so you get z equal to 1 plus I, and then this is a 45 degree, right? This is a 45 degree, or pi over 4 radian. So which of the following is the correct polar form of z? So the modulus of the complex number, or the distance from O to from 0 to z, can be calculated by this hypotenuse. You can say the modulus is set 2, the angle is 45 degree, right? So this is a this is a 45 degree, sorry. Okay, so 45 degree or pi over 4 radian. So this is the in polar form. When you inspect here, actually A and D is correct. So why B is wrong? Because this is 45, we should put the degree if you want to express it in degree. Or if you put it in radian, you don't need this degree. Okay, so it doesn't matter the argument of the complex number in degree or in radian. So if you put in degree, you have to put the units there. But if you use the radian, you don't need it. Okay, so good luck.